to the Alpha booth here at Apex 2017. I'm delighted to be joined by Robert Wallace. Nice to see you again, Robert.
Good to see you, Trevor. Welcome.
Thank you. So I believe one of the things you're celebrating here this week is the 40-year-old birthday of the Alpha logo. I know you refer to it as a worm internally, which is not particularly nice. But
Trevor, we're excited. Absolutely, yeah. It's kind of the birthday year for the worm. We affectionately refer to it as a worm. So that A logo came into existence 40 years ago, Trevor. It's been a long time, and certainly is well known throughout the industry worldwide. Alpha came into existence actually as I. Schomburg Company in 1872. Wow. And since then, and that was a metals reclamation company at that time. Since then, obviously we changed it a little bit. And then about 40 years ago to the day, we came up with the Alpha worm, and we've really followed the growth of the electronics industry since then.
Yeah, so and you've had quite a long, illustrious career, so congratulations on that. So I want to get down to some of the materials we're talking about here today on the booth, and one of the most topical areas in the business at the moment is low voiding. It's a real problem. So maybe you've got a new product out here, I believe. Maybe you can tell us a bit about it.
We do, Trevor. What we're introducing at the show is what we call OM358 solder paste. And really the performance attribute that we targeted for this material was for low voiding performance when you match that with our Maxrel alloy. And Maxrel, as you're probably familiar, is really the Inalot alloy. And historically, when you match that alloy with some of the other solder paste that we commercially had available, the voiding performance really wasn't what we were hoping for, right? Or so it did have a little bit of a voiding issue. So the OM358, Trevor, was targeted for low voiding performance. We achieved that, and as a matter of fact, we have about a 50% lower voiding rate with the Inalot alloy with the OM358. You look at the other performance attributes of that material, Trevor, not only low voiding performance, it's a broad latitude product. When you match that with SAC 305, we actually have about a 15% instance of voids compared to some of the other products that we offer. So from a voiding performance, from a broad latitude performance, it's a great performing material, Trevor.
Right. Okay. Well, most of these low voiding materials, really the component that goes towards it is the flux medium. So how much of this is flux and how much of it is the paste?
Well, it's typically the flux, right? So when you're looking at the flux mechanism, again, when we formulated this material, and Trevor, when we're designing a solder paste, and specifically the flux, to achieve certain performance attributes, then if we know what we want to accomplish, right, and we have that goal, then we're going to formulate that paste to achieve that goal. In this instance, not only do we reduce the amount of voiding, especially with the Inalot alloy, but all other performance attributes combined, it's a broad latitude material, like I said, air reflowable in type 4 and type 5 powder with SAC 305. So we think we got a great winner here.
Right. Well, we've actually got some information about it on here, maybe with some of the key attributes here. So is there anything we've missed?
Well, exactly what I had said, Trevor. You can see the difference in voiding with the OM358 when you talk about the performance with the Inalot material, but ultra low voiding, high reliability. So it certainly meets J Standard 004B. Excellent printing, like I said, a broad latitude material. And then the cosmetics are great, pin testable. So all attributes combined, it's a great product.
Yeah, sounds like an all-round good performer, quite frankly. But we're not just limited to the paste. I believe you've also got another one here. It's the preform material.
I'm glad you mentioned that, Trevor. We have what we call our AccuFlux preforms. And so when you're talking about void reduction, and this is very important when you're talking about power modules, right? And this is AC to DC inverters, right? When you have high current and high cycles and high current, and you need that performance, that voiding performance, because those large pad areas under these devices are intended, obviously, to pull the heat away, right? So if you have voids in that junction or that joint, it could, certainly impede or it affects the ability of heat dissipation. Right. So the AccuFlux preform, what we've done here, Trevor, it's pretty novel, right? we are able to supply these, and they're typically 10 by 30 millimeter, right?
Okay.
So it's a large form factor, certainly larger than other preforms we have on tape and reel, and we have a flux mechanism that these preforms are coated with, and you can use your pick and place equipment, and it does not affect the placement, the pick rate, due to, you would think if it has flux on it,
Right.
then it affects the placement equipment. It doesn't, right?
I mean, flux is usually a sticky material. And
It is. This is a dry coating, right? So we put those in that form factor. AccuFlux preforms, you use those and you don't really need to paste anything because it has flux on it. That virtually eliminates the voiding that you would see on that particular device, on that particular pad.
Right. Okay. Well, that's certainly interesting. So, what's the model? The name of this? This is AccuFlux preforms.
AccuFlux preform.
Yeah.
Again, about 10 by 30 millimeters, available on tape and reel. Really, we're talking about heat dissipation and the performance of that. So the voiding performance, especially for pulling away the heat, is critically important. We eliminate voids by the use of an AccuFlux preform.
Great. So I'm guessing this is driving up reliability and different things like that.
I'm glad you said that, and certainly it does, right? And the performance of the material, or the performance of the end product. When you're talking about reliability, Trevor, at last year's show we talked about the material set combinations that we have, right? And what we've done is taken our solder paste, or one of our leading solder paste, Flux, all the materials that you would use in the soldering process, we put those in combination and we run those to J Standard 004B. All products are going to pass J Standard 004B by themselves, right? But the trick is sometimes when you put that in combination, Trevor, sometimes those materials don't play well together. And not all customers have the wherewithal to perform that testing themselves. We take the guesswork out of it for you. We have a couple different material sets that are fully tested to J Standard 004B together.
That's interesting because one of the big topics at the show here, of course, has been the smart factory business, and it's the digitization of the factory. In the moment, it's at a machine-to-machine level, but there's no doubt that once we're finished optimizing the equipment, this is going to drill down to a materials level.
Yeah, absolutely.
And in particular, identifying material sets, where you might be using an alpha paste with a Henkel underfill, and what's the likely CTE mismatches and the percentage of success you're going to have with that. And it'll be very much data-driven. Do you think that is pretty much the way that the industry is going to go, and somebody's going to write the gene map of electronics materials?
I believe we're evolving every day, right? There's certainly the advancements in the electronics industry is staggering when you consider really how old the industry is in terms of the assembly industry, and we keep pace with that, Trevor. Not only from a technological standpoint, we're the industry leaders. If you look around the booth, we have a timeline of our first-to-market achievements, right? And so we've been on the cusp of the changes as the electronics industry and the assembly industry evolve, right? But for really what it means to us, right? Those changes are going to occur. There's going to be new technology, emerging technology, but really it comes down to basics. Are we supplying materials that when they're used in combination are reliable, right? But not only that, but as much machine automation you want to put in, there's still a human involvement, and there's still an opportunity, for us to go in and train customers on the proper use of our materials.
Well, that comes down to your customer care side, isn't
Absolutely,
it?
it does.
So how does that work within Alpha?
Well, we have a team of degreed professionals. These are engineers that spend time with our customers out on their production line. They came from a production environment. They know the difficulties sometimes in producing quality boards, given the different materials, given the different things that can go wrong, not only with materials but boards and so forth. So we want to ensure that our materials are reliable. We also want to make sure that they perform to the customer's expectation. And how we do that is service after the sale, if you will. We have our customer tech services engineers, from our tech services group, like I said, they go out on the production floor, they train, they get involved, they troubleshoot, and that's the value, Trevor, that we bring to our customers.
Right. Well, that's incredible. So a lot going on here at Alpha, a lot to celebrate, but also a lot to look forward to.
Come back for the birthday party for the worm. Yeah, we'll have you blow out the candle. How's that?
There you go. That sounds like a plan. Robert, thank you for joining us. It's been great. Thank you.